All right, in this example, we're given a graph of the derivative. So make sure you notice that this is the derivative. This is not f of x. This is f prime of x. So we're given the graph of the derivative and we're asked to identify the critical points, find the intervals where f is increasing and f is decreasing, and also classify the critical points as either local minimum, local maximum, or neither. All right, so remember, this is the derivative. All right, so where does the critical points are where the derivative equals 0. So this point right here, right, the derivative is 0, right? So this is a critical point. And here the derivative is also 0. This is the critical point. Remember, we're not looking at the slope of this function because this is the slope. This is f prime of x, and we're being asked questions about the original function f. Okay, so now we're kind of working backwards. We're taking the derivative and we're trying to get information about the original function. Okay, so the critical points are where the derivative is 0. So we're going to say that we have a critical points at x equals -1 and 1. All right. So those are our critical points. And now I can just do like what I've done before, just draw a little number line. I'm going to break the domain of the function, the original function, into 3 parts by breaking it here at the critical points. Okay. And then I can look at the graph of the function, in fact, the graph of the derivative here. This is the graph of the derivative, and I can look at where it's positive and where it's negative to determine the slope of the original function, right? So you can see that these values here, f prime is greater than 0, right? Because these, on this portion of the graph, when x is less than -1, right, the values of f prime are positive, right? If they're positive, that means that f is increasing. Okay, so then I'll draw a little arrow to indicate with a positive slope that indicates that the function f is increasing. All right, now between -1 and 1, the values of the derivative are negative, right? If the values, I'll write that down, f prime is less than 0 down here, right? Because it's below the x-axis, so the values, this is the graph of the derivative, then the y values are the values of the derivative. So these y values are negative, which means the derivative is negative of the original function. Okay, so now if it's negative, then the original function is decreasing. So I'm going to draw a little arrow with a negative slope. And then finally, when x is greater than 1, these values are again positive, right? F prime is above the x-axis, so the values of f prime are positive, which means the original function has to be increasing. Okay, so it can get a little confusing because we're looking at f prime of x. We're not looking at f of x. You have to keep in mind we're looking at f prime of x. So, and then we're trying to figure out, okay, what's happening with the original function f of x. All right, so based on the first derivative test, now I can classify my critical points, right? I have a local maximum at x equals -1, and I have a local minimum at x equals 1, right? Just based on the first derivative test. Okay. Now we don't have enough information to determine what the y values are, right? Because all we're given is the values of f prime. We don't know what f of x is. We could kind of imagine what the general shape of f of x is because we can tell from these arrows. That's kind of why I draw the arrows the way I do, because you can tell that the function has to be increasing, decreasing, increasing again, right? So, and I have to have a minimum here and a maximum here, right? So if I was going to draw the general shape of the function, it would look something like this, right? But I don't have enough information to determine any y values. So all we can do is determine the x values of the local minimum and local maximum, and we don't know anything about the y values, so we don't have to worry about that. All right, I will meet you in the next video.